Quick revision for all content of paper 2 AQA GCSE Chemistry exam. The rate of the reaction, the graph of the rate of the reaction is a common exam question where they give you the graph for a certain reaction, either with the amount of product formed over time or the amount of reactant as it changes over time, and they ask you to draw another graph with changed conditions. So if you are going to draw a graph for an increased rate or a higher rate, remember to draw a steeper line, and also the highest concentration would be reached faster. If the concentration increases, that means more product will be formed. In this case, not only a higher rate will be formed, but also the maximum amount of product produced will be higher. If they ask you to find the rate from the graph at a certain time, then you need to draw the tangent at that specific time, and then you need to find the slope at that tangent, so the change in y over the change in x. The different factors that affect the rate of the reaction. Remember that the rate of the reaction, when you talk about the different factors, you need to talk about the particles and their collision. So let's start with the increase in the temperature. Increasing temperature will increase the rate of the reaction. This is because um, with higher temperature, the particles will have higher energy, so they will start to move faster. Faster moving particles means that more collisions will be found between the particles, or more frequent collisions. Also, the collision will have enough energy for the reaction to start. So basically, they're going to have more than the activation energy. If you increase the pressure or the concentration, remember that the concentration here when we are talking about solutions, and the pressure is when we are talking about gases. So in case of solution, if it's more concentrated, that means that there are more particles knocking about in the same volume of the solvent. So there will be more frequent collisions, so the rate of the reaction will increase. In case of pressure, it's the same thing. So for pressure, it will be the same number of particles as well, but in a smaller space, so more frequent collision, and so the rate of the reaction increases. The surface area, increasing surface area will also increase the rate of the reaction, because surface area to volume ratio will increase. So for the same volume of the solid, as we can see here, the particles will have more area to work on, so more frequent collision, so the rate of the reaction will increase. Finally, the use of a catalyst. The use of the catalyst, it will increase the rate of the reaction. It does so by lowering the activation energy for the reaction. It does this by using or providing an alternative pathway for the reaction with a lower activation energy. Remember that a catalyst is a substance that speeds up the reaction or increases the rate of the reaction without being used up in that reaction. So what is equilibrium in relation to reversible reaction? Equilibrium is reached when the rate of the forward reaction is exactly the same as the rate of the reverse reaction, and when the concentrations of reactants and products are constant. They are not the same, they are just remain constant. So at equilibrium, there's a reversible reaction, and as we can see that the rate of both reactions, forward and reverse, are the same, and the concentration remains constant. The position of the equilibrium could be either toward the products or towards the reactants. There are certain factors that affect where the position of the equilibrium will be. This is called Le Chatelier principle. Le Chatelier principle states that if a system is at equilibrium and a change is made to any of the condition, then the system will respond to counteract that change. So if we increase the concentration of the reactant, for example, the system is no longer at equilibrium because the concentration of reactants and products are not constant, they have changed. So to counteract that effect, the forward reaction, the position of the equilibrium will be pushed toward the forward reaction, so more product will be produced in this case, and vice versa. So if we add more of the product, then the position of the equilibrium will be toward the reverse reaction or towards forming more of the reactants. The second effect is the effect of the pressure on the equilibrium. We are here talking about gases and reaction between gases. So if you increase the pressure, the reaction will be pushed to the direction where less number of moles will be produced. So this is an example here, a reaction between nitrogen and hydrogen to give ammonia. Now, the reactant, there are 4 moles of reactants, but only 2 moles in the product. So if we increase the pressure, then the equilibrium will shift to the sides where there is less of number of moles, so towards the product, so higher yield of the product. If the pressure is decreased, then the reaction to counteract the effect, the position of the equilibrium will be towards the formation of the reactants in this case. And finally, the effect of the temperature on the equilibrium. So that will depend on whether we have an exothermic or endothermic reaction. So for a reverse reaction, a reversible reaction, one side will be exothermic and the opposite one will be endothermic. So if we increase the temperature, then that means that more heat was produced. The reaction is not at equilibrium anymore. So the reaction will have to shift towards the endothermic side. That means if the forward reaction is exothermic and we increase the temperature, then the position of the equilibrium will be towards the reverse reaction or towards the formation of the reactants, not the products, and vice versa. So if we decrease the temperature, then the reaction would need more heat here. So the equilibrium will be shifted towards the exothermic reaction or towards formation of the product. For organic chemistry, first of all, you need to know how to represent different organic molecules. The most important ones are the molecular formula and the general formula. The general formula is the empirical formula that represents the composition of any member of an entire class of compounds. For example, for alkenes, it's CnH2n. So it's very important to know the general formula, and then the molecular formula will give you exactly the exact number of all the elements within your compound. Remember that homologous series are series that have the or different compounds which all have the same general formula and the same functional group. So then you can use the general formula to work out the molecular formula depending on the number of carbon atoms. They only differ by CH2 in the molecular formula from the neighboring compound, and they show a gradual variation in their physical properties, such as boiling points. And finally, because they all have the same functional group, they react similarly or they have similar chemical properties. The first two homologous series we need to know are the hydrocarbons. Remember that hydrocarbons are these compounds which have only carbon and hydrogen in their structure. We have the alkanes, which are called saturated hydrocarbons because they only have single bonds. There are no double bonds. Alkenes are the other homologous series from the hydrocarbons, which are called unsaturated hydrocarbons. They are unsaturated because they have this double bond between the carbon atoms. Let's compare between alkane and alkenes and starting off with the naming. So how to name alkane and alkenes? Remember that we need to use a prefix, and the prefix is used for the first part of the name, and this is related to the number of carbon atoms in the chain. So if you have only one carbon atom, it's meth, two carbon atoms, eth, three, it's prop, and four is bute. For alkanes, then the suffix is going to be ane, so you add the prefix with the suffix, so you have methane, ethane, propane, and so on. For alkenes here, which have the double bond, the suffix here is ene, and to name it, use the suffix, the prefix with the suffix, so it's going to be ethene, propene, and butene. Remember that you cannot have methane, you cannot have an alkene with only one carbon atom. So the first member of the homologous series is ethene. For the general formula for alkanes, it's CnH2n. N plus 2, and for alkenes, because there is a double bond, there is 2 hydrogen less, so it's CnHn. Now let's look at the different physical and chemical properties and compare between them. So first of all, the boiling point and viscosity. For both alkane and alkene, there will be an increase in the boiling points and viscosity with the increase in the carbon atom in the chain. And this is because increasing the carbon atom in the chain means there is an increase in the intermolecular forces of attraction between the molecules. So you will need higher energy to break these bonds, and so the boiling point and also the viscosity will increase. Complete combustion, both of them can undergo complete combustion, and the product and complete combustion usually take place in presence of excess oxygen, and it will give carbon dioxide and water in addition to heat or energy. This is an exothermic thermic reaction, and remember that's why alkane and alkenes can be used as fuel because of the complete combustion and production of heat. In complete combustion, when there isn't enough oxygen, then the products here will change. The alkane and alkenes will give carbon monoxide instead of carbon dioxide and water, so they will give carbon monoxide in addition to carbon dioxide and water, or it could give carbon monoxide and water as products. Less heat will be produced, and the problem with incomplete combustion is that carbon monoxide that is produced is a toxic gas that can cause suffocation. For chemical reactions, we have also the addition reaction. Addition reaction is a reaction when something, a small molecule, is added to a double bond. So for addition reaction, you can see that alkanes don't have any double bond, so they do not undergo addition reaction. There is no addition reaction for alkanes. Alkanes, however, because they have the double bond, we can add small molecules to this double bond where the double bond breaks and new bonds are formed where the new atoms are added. So when you add chlorine, that will give you dichloroalkane. So if you have a double bond like this, you simply break it and then replace it with two chlorine atoms. And if it's water, that will give you alcohol where you add hydrogen to one carbon and OH to the other carbon. And then if you have bromine, that will give you dibromoalkane. The test that is very important for you to know is the test for the double bond, which is the bromine water test. Bromine water test is used to test for double bond or test for alkenes. Of course, alkanes, because they don't have double bond, they will not give any positive test. It's going to be negative. There will be no change in the color. However, with alkenes like ethene here, when it reacts with bromine, it will give you the double bond will be broken and bromine will be added to give you di bromo ethane. So bromine water color will change from orange to colorless because there is no bromine anymore. So the color will change from orange to colorless. How do we get the hydrocarbons? We get them from the crude oil. And to get the different alkanes from crude oil, we need to separate the crude oil into fraction because crude oil is a mixture of so many different hydrocarbons with different chain lengths. So to do this, the process of fractional distillation of crude oil, you start off by heating the crude oil in a furnace and vaporize it. The vapors will rise into the fractionating column where there is a temperature gradient within the column with higher temperature at the bottom and lower temperature at the top. The different fractions with different boiling points will be cooled down and condensed and collected at different points in the fractionating column. As you can see, as we go down the column, the boiling point and the viscosity will increase. Because most of the fractions that are obtained from the fractional distillation of crude oils are the long chain hydrocarbons, which are less useful than the shorter chain hydrocarbons, which are used as fuel. So we need to do cracking, where cracking is breaking down of the long chain hydrocarbons to give shorter chain hydrocarbons. To achieve cracking, you need to heat the long chain hydrocarbons to vaporize them. And then the vaporized hydrocarbon are either passed over a hot catalyst like silica or alumina, where there is a catalytic cracking where the long chain hydrocarbon will break down to give shorter chain hydrocarbon and an alkene. Or the vapors are mixed with steam and heated to a very high temperature, the temperature in the range of 600 to 700 degrees, so the thermal decomposition reaction can occur. So the products of cracking are shorter chain alkane and the alkenes. Remember that the alkenes can be used for making polymers as well. So cracking is not just to make shorter chain hydrocarbons, but also to make alkenes, which are used in polymerization or in making polymers. Alcohols is another homologous series. In alcohols, the functional group here is the OH. To name alcohols, you need to remove the E from the alkane name and replace it with oil. So for ethane, two carbon atoms, you remove the E and then you replace it with ol, so it's ethanol. So examples, methanol, ethanol, propanol, and butanol, depending on the number of carbon atoms. Ethanol can be used as fuel because it undergoes complete combustion to give carbon dioxide, water, and heat. It's very important to know how to produce ethanol. Ethanol is produced by fermentation of glucose using yeast. So glucose will give you carbon dioxide and ethanol. These are the product of the fermentation. The yeast here is important because it provides the enzyme needed for the process of fermentation. So there are optimum conditions for the fermentation because it's an enzymatic reaction. So first of all, the temperature. The optimal temperature is 25 to 35 degrees. Low temperature will make the enzyme inactive, and high temperature will cause will denature the enzyme, so it becomes inactive as well. And also this reaction or the fermentation needs to be done in the absence of oxygen because presence of oxygen will oxidize ethanol to give ethanoic acid, and it will not stop at the stage of formation of ethanol. So to obtain ethanol, you need to run the fermentation in the absence of oxygen or under anaerobic conditions. Carboxylic acid is another homologous series. Carboxylic acid, they have the COOH functional group. This is the functional group for carboxylic acid. They are named by removing the E from the alkane and replace it with oic acid. For two carbon atom carboxylic acid, it's called ethanoic acid. They are formed by the oxidation of alcohol. So if you oxidize alcohol, that will give you carboxylic acids. Remember that carboxylic acids are still acids, so they have typical acid properties, but they are weak acids, not strong acid. So first of all, they will dissolve in water to give acidic solution with pH less than 7. They will react with bases, for example, metal oxides and metal hydroxide to give salt and water. They react with metal carbonate to give salt, water, and carbon dioxide. So ethanoic acid with sodium carbonate will give sodium ethanoate. This is the salt of ethanoic acid, carbon dioxide gas, and water. They react also with metal to give salt and hydrogen in the same way like acid. So ethanoic acid with sodium will give you sodium ethanoate and hydrogen gas. Ester is the last homologous series you need to know. They have the COO functional group. They are formed from a reaction between a carboxylic acid and alcohol. So a small molecule of water is removed here. The OH comes from the carboxylic acid and the hydrogen comes from the alcohol. And then a new bond is formed between the oxygen of the alcohol and the carbon here from the carboxylic acid to form the ester. This is the ester functional group, which is COO. To name the, in addition to water, of course, this is the small molecule that is produced from the reaction. So to name esters, first of all, you need to start with the name of the alcohol by removing anol from the alcohol name and replace it with il. So for this one, for example, we have the ethanol, so we remove anol and replace it with il, so it's ethyl. And the second part will be the carboxylic acid name, and we remove the oic acid and replace it with OH. So here we have ethanoic acid. So we remove oic acid and replace it with OH. So it's going to be ethanoate. So the name for the ester here is ethyl ethanoate. There are two types of polymers. There is addition polymers and there is the condensation polymers. Polymers in general are formed by joining up many small molecules together, and these small molecules are called monomers. So they are formed of repeating units. So for addition polymers, the repeating units or the monomers that are added together are usually alkene. We usually use one type of alkene and it's added to each other to give you the polymer. To draw the structure of the polymer from the monomer, or what you need to do is to remove the double bond from the alkene and replace it with a single bond, and then add extra two single bonds to the both sides of the carbon atoms, and then you add the brackets and the letter N, which refers to the number of the monomers that are added together. So ethene will give you polyethene, propene will give you polypropene, and so on. You don't need to worry about the different substituents here. They give you in the exam whether it's hydrogen or anything else. Just focus on this double bond and then you just add the substituents whatever they are. So if there is a CH3 here, for example, for propene, then you just need to add CH3 here on that side. Condensation polymers. In condensation polymers, a small molecule is formed in addition to the polymer. Here in condensation polymer, we react a dihydroxyl compound with a dicarboxylic acid compound, and they react together to give ester, and then a small molecule of water is removed here in this reaction. Then again, there is a repeating unit, which is the ester. An example of that is PET. In PET, we have this dicarboxylic acid and we have this dialcohol, and then the water molecule is removed. As we can see, this is the new ester that has been formed. When you draw the polymer, remember that for the ester, only the hydrogen is removed, or when the water molecule is removed, the hydrogen is removed from the alcohol. So you just need to add the oxygen here with a single bond from that side. And for the carboxylic acid, we remove the OH. So you need to draw the carbon with the double bond O, and then this single bond here. Open the brackets and write the letter N again. Don't forget N water molecules will be removed as well. Naturally occurring polymers, we have the protein first. Proteins are formed of polypeptide chain, and they are formed of a condensation polymers between amino acids, where a peptide bond is formed and then a water molecule is removed. We have different amino acids which are joined together to form the polypeptide chain, which is a type of condensation polymers. This is naturally occurring polymers. We also have the DNA, and when they ask you about the DNA is formed of two polymer chains of monomers called nucleotide. And then the two polymer chains, the nucleotides, are connected together through hydrogen bonding between nitrogenous bases, which have the letters C, G, A, and T. Chemical analysis. First of all, testing for the purity of a substance. A pure substance is a single element or a compound not mixed with any other substance. And we can test the purity of a substance by measuring the melting and the boiling point of that substance. So if the melting and boiling point is the same as the one we can find in the data book, then that means that the substance is pure. It doesn't have any impurities. Remember that impurities will decrease the melting point of the substance and the sample will melt over a range of temperature. However, it will increase the boiling points of the substance and the sample also can boil over a range of temperature. Formulation is a different thing. Formulation is a specific type of mixture that has been designed as a useful product. So each component in a formulation is present in a measured quantity and it will contribute to the property of the formulation so it can meet its required function. Some examples of formulations are fuel, cleaning agents, paints, medicine, and so on. All of these are formulations. Paper chromatography is an analytical technique that is used to separate components or compounds by their relative speed of movement in a solvent as it is spread through a paper. So you have the different component, they have different affinity or they have different attraction to the solvent and to the paper. And as if it has more solubility in the solvent, it will move faster through the paper. If it has less solubility, it will move slower. We measure the distance that is traveled by each component, and then we can say whether we have a specific dye or a specific component in that mixture or not. The very important notes for the paper chromatography, which usually come many times in the exam, that you need to remember that the start line for the chromatography need to be drawn in a pencil, not a pen, because the pen will have dye that can dissolve in the solvent and that can disturb the paper chromatography. Also remember when you immerse your paper in the solvent, the start line has to be above the level of the solvent. Otherwise, the different spots will also dissolve in the solvent and that can disturb the paper chromatography. We need to know how to measure the RF. The RF is the distance moved by the spot over the distance moved by the solvent. So the distance moved by the spot is the distance between the start line and the center of the spot, and the distance moved by the solvent is the distance between the start line and the solvent front. Solvent front is where the solvent moved in the paper chromatography. The different chemical tests that you need to know for your exams. First, test for gases. So hydrogen gas, you have a light splint next to the hydrogen. The hydrogen will give you a squeaky pop sound. For oxygen, you have a glowing splint and the oxygen will reignite the glowing splint. Chlorine will bleach a litmus paper, and the carbon dioxide, you bubble the gas through lime water. Carbon dioxide will turn the lime water cloudy. Test for metals. First, the flame test. Different metals will give the flame very specific colors. So we have lithium will give you crimson red flame. Sodium will give you yellow flame. Potassium will give you lilac flame. And calcium will give you orange red. And copper will give you green. You need to memorize these colors. Another test for the metals is the sodium hydroxide test. So some metals will give a distinctly colored precipitate with sodium hydroxide. So if you add sodium hydroxide solution to a solution of a compound that has a certain metal, that will give you a precipitate with a certain color. So if it gives you a white precipitate, then you could have either calcium, aluminum, or magnesium. However, there is a specific test as well, or an additional test or an additional step to identify the aluminium, because in aluminium, if you add excess of sodium hydroxide, in case of aluminium, that will give you a clear solution. So only aluminium will give you the clear solution if you add excess of the sodium hydroxide. Calcium and magnesium will remain with the white precipitate. Also, we have copper 2 plus will give you blue precipitate with sodium hydroxide, iron 2 plus will give you green precipitate, and iron 3 plus will give you brown precipitate with sodium hydroxide. Test for anions. First of all, testing for halides. Halides are chloride, bromide, and iodide. First of all, you need to add dilute nitric acid, and then you add silver nitrate solution to the solution of the halide compound. If it gives you white precipitate, then it's going to be chloride. If it's cream precipitate, it's bromide. If it's yellow precipitate, it's going to be iodide. Don't forget how to write the ionic equation for such reactions or for such tests. So you only need, if it's ionic equation, you only need to write the ions that react, which is the iodide in this case, and what that it's aqueous because it's a solution, and then the silver aqueous as well, which is because it's in solution, and the product is going to be silver iodide, which is solid because it's a precipitate. Then test for sulfate ion. First, you need to add dilute hydrochloric acid followed by barium chloride solution. This is barium chloride test. A white precipitate will form from which is the barium sulfate. Test for carbonate, you need to add dilute acid like HCl. Carbon dioxide will be produced. You need to bubble the gas, which is the carbon dioxide, through lime water. The lime water will turn cloudy. So this is test for carbonate. Also, it's very common to ask you about the instrumental test for metal ions. So elements and compounds can be detected using instrumental techniques. Instrumental techniques are better than the chemical test because they are more accurate, they are sensitive, and they are rapid. The name of the test that we use is the flame emission spectroscopy. You just need to know the name of the test and their advantages. Topic 9. So the Earth early atmosphere at the beginning of life, the atmosphere of Earth was mainly carbon dioxide. And then due to volcanic activity, nitrogen started to increase and also water vapors were formed and water vapors started to condense and to make oceans. The next stage is that carbon dioxide started to decrease. Carbon dioxide decreased because carbon dioxide is a very soluble gas and carbon dioxide dissolved in water and they formed sedimentary rocks. Also, the algae and the plants in the water started to take up carbon dioxide to make photosynthesis. So carbon dioxide concentration decreased. Later on, the oxygen concentration started to increase, and this is because with the evolution of the plants and also with the algae and all of the different plants, algae and plants started to take up carbon dioxide through photosynthesis and to produce oxygen. So the concentration of oxygen in air started to increase. You need to know the difference between the formation of the crude oil and coal. So how did crude oil formed? Crude oil formed from the plankton or the dead and decoying organic matter from the under the ocean organisms, which we call plankton. So they died from millions of years, and then they were covered by sedimentary rocks. They were subjected to high pressure and temperature, so they have changed to give you the crude oil. Coal was formed differently because coal is formed from the plants and the swamps from 300 million years ago. The dead plants were then covered by dirt and by rocks, and they have been subjected to high pressure and temperature, and then they formed the coal. The greenhouse gases, we have three different greenhouse gases. The most important ones are carbon dioxide and methane. The greenhouse gas effect, the greenhouse gases are important to keep the temperature on Earth warm. So how does the effect of the greenhouse gases take place? So first, the electromagnetic radiation that comes from the sun will pass through the Earth's atmosphere and they will be absorbed by the Earth. Some of these wavelengths, specifically the IR or the infrared wavelengths, will then be radiated back from the Earth. As they are radiated, some of it will then travel to space and some of them will be absorbed by the greenhouse gases like carbon dioxide and methane. The carbon dioxide and methane then will absorb these and then will reflect them back into Earth, leading to an increase in the temperature in the lower atmosphere. So the higher the concentration of the greenhouse gases, more infrared radiation will be irradiated back into Earth and the temperature of Earth will increase. There are certain human activities that will contribute to an increase in the greenhouse gases in the atmosphere. So, any activity that will increase the level of carbon dioxide or methane will contribute to the increase of the greenhouse gases. So, farming cattle will increase the level of methane, burning rice, methane, burning fossil fuel, carbon dioxide, decomposition of organic matter in landfill, methane, and deforestation, of course, will increase the level of carbon dioxide. The footprint and its reduction. Carbon footprint is the total amount of carbon dioxide and other greenhouse gases emitted over the full life cycle of a product, service, or an event. So we can reduce the carbon footprint of any product if we decrease the emission of or decrease the activity that leads to the emission of carbon dioxide. For example, using less fossil fuel, reduce the amount of the travel and transport, or planting more trees. However, these measures might be challenging because it might be more difficult to implement. It can be much more expensive, and then planting more trees means that we will take away land that can be used for growing crops. Using something like solar panels may take large spaces, and they also renewable resources like the sun may not be reliable. The different atmospheric pollutants from fuel. So most fuels contain carbon, hydrogen, and they also may contain sulfur. So combustion of fuel is a major source of atmospheric pollutants. Most of these are carbon dioxide, which is responsible for the global warming and climate change, carbon monoxide, which comes from the incomplete combustion, and it's a toxic gas that can cause suffocation. Carbon particulates, also from incomplete combustion, they will cause global dimming and respiratory problem. Sulfur dioxide, they come from the using burning fossil fuel because it contains some sulfur. The sulfur dioxide is responsible for the acid rain, which can cause corrosion of buildings and statue, and also that can affect the pH of the water and affect the fish or the aquatic ecosystem. Nitrogen dioxide as well is one of the gases that are emitted from burning fossil fuel in cars because of the high temperature in the engine. Nitrogen and oxygen from air will combine together to give nitrogen dioxide, and nitrogen dioxide as well is one of the causes of the acid rain. So it has the same impact as sulfur dioxide. The Haber process is an industrial process for the formation of ammonia. Ammonia is used to make fertilizers. In the Haber process, nitrogen gas reacts with hydrogen gas in a reversible reaction to give ammonia and heat. So it's an exothermic reaction. These are the optimal condition for this process, which is 450 degrees Celsius to 100 atmosphere pressure, and the use of an iron catalyst. Looking at the stages of the Haber process, so nitrogen that comes from air and hydrogen that comes from natural gases are mixed together, and then the pressure is increased to 200 atmosphere, and then the temperature is increased to 450 degrees, and they are allowed to react together by the aid of an iron catalyst beads. So here this is a reversible reaction. So hydrogen and nitrogen will react together to give you ammonia. However, at the end, we still gonna have nitrogen, hydrogen, and ammonia because this is a reversible reaction. So to separate the ammonia from hydrogen and nitrogen, we only need to cool the mixture, where ammonia can be liquefied because it doesn't have a very high boiling points. So it can be liquefied and ammonia can be taken out, while hydrogen and nitrogen can be recycled. They stay as gases, and then they go back and recycle and go back to the same reactor to carry on reacting together. So what are the different factors that affect the process? How can we increase the yield, and why 450 degrees, 200 atmosphere pressure, and the use of the catalyst? So let's look at the different factors. First of all, if we use very high temperature, that will increase the rate of the reaction because we know that higher temperature increase the rate of the reaction. However, it will decrease the yield because this is a reversible reaction and the forward reaction is exothermic reaction. So increasing temperature will push the direction or the position of the equilibrium towards the left-hand side or towards the reactant. So the yield will decrease. The cost, however, will also increase if we increase the temperature. Lower temperature will reduce the rate, but it will increase the yield because it will favor the exothermic reaction. The cost here will be decreased. So to balance for the temperature between the rate of the reaction, yield and cost, the temperature of 450 degrees is used. Pressure, if we use high pressure, that will increase the rate of the reaction because we have here, as we can see, pressure increases the rate of the reaction, and the yield also will increase because this reaction will favor, increasing pressure will favor the side which has a lower number of moles, which is the side of the product, but the cost of the process will increase if we use very high pressure. If we reduce the pressure, the rate of the reaction will decrease, the yield will decrease because it's going to favor the reverse reaction in this case because there are more moles here in the reactant side, and the cost will decrease. So to balance between the cost, yield, and rate, we need to use 200 atmosphere pressure. Finally, the use of the catalyst, we said we use iron catalyst. So the catalyst will increase the rate of the reaction because we know that the catalyst will lower the activation energy. However, the catalyst doesn't affect the yield of the product, has no effect on the yield because it increases the rate of the forward and the reverse reaction at the same rate. So there is no impact on the yield at the end. So these are the optimal condition, and the use of the catalyst will allow us to increase the rate and allow us to use lower temperature. So that will reduce the overall cost of this process. Fertilizers are formulations that will provide mineral ions needed for the healthy growth of plants. The most important type of fertilizer are these ones which contain nitrogen, phosphorus, and potassium. They are called NPK fertilizers. N for nitrogen, P for phosphorus, K for potassium. So these fertilizers have to be soluble in water so they can be taken up by the plants. So we need these three elements to be in the form of soluble salts. The source of the nitrogen will be either ammonium ion or the nitrate ion. The source of the phosphorus will be the phosphate ion. The potassium can come from any potassium compound that is soluble in water. So these are some examples of fertilizers and which element they provide. So ammonium nitrate, here we can find that there is only nitrogen. Ammonium sulfate, also only nitrogen. Ammonium phosphate, we have nitrogen and phosphorus. And then potassium nitrate, we have potassium and nitrogen. Phosphate rock cannot be used as a fertilizer because it's insoluble in water. However, it can be used to make fertilizers because phosphate rocks, because they are insoluble, they can react with acids to give you soluble compounds. You need to know the different acids and what are the product when the phosphate rock react with that particular acid. So if it reacts with nitric acid, that will give you calcium nitrate and phosphoric acid. If it reacts with sulfuric acid, that will give you single superphosphate. If it reacts with phosphoric acid, that will give you triple superphosphate. Making ammonium sulfate in the chemical industry. Ammonium sulfate, as we said, is one of the filterizers. It can be made industrially by a reaction between sulfuric acid and ammonia. But in the industrial process, we will start with the raw material. So ammonia can be formed through the Haber process, as we discovered from a reaction between nitrogen and hydrogen, and sulfuric acid can be done by a reaction between sulfur and oxygen to give sulfur trioxide, and then sulfur trioxide can dissolve in water or react with water to give sulfuric acid. Finally, sulfuric acid react with ammonia, and that will give you ammonium sulfate. This is a continuous process, and the ammonium sulfate is continuously produced. Ammonium sulfate can be made in the lab as well, but it's a very tedious process and we can only use it to make batches, small batches. The process is through the reaction between ammonia and sulfuric acid as well. However, in the laboratory, you need to react a measured volume of ammonia with a measured volume of sulfuric acid. So to compare between making ammonium sulfate in the lab or the industrial process, you need to focus here on the advantages and disadvantages. So for the industrial process, it's going to be a continuous process. The starting materials, but however, in the laboratory, this is just a batch process. The starting materials, all reactants are made from raw material like sulfur, air, and water. However, in the laboratory method, the reactants have to be purchased. The scale and yield, the industrial process will produce large or huge quantities, which are made quite quickly, but in the laboratory methods, only small quantities are made, which is very slowly. Of course, the running cost, the industrial process is automated control mechanism, and it's a continuous process, but in the laboratory, it's very labor intensive and the running cost will be very high. The life cycle assessment, it's a complete analysis of the impact of the manufactured product on the environment. There are four stages in the life cycle assessment. First, the extraction and processing of the raw material, and then the production of the product itself, then the consumption, and finally the disposal. In each of these four stages, the life cycle assessment is likely to include information about the use of energy, the transport of the material, and the release of the waste in the environment for all of the four stages. So this is an example for the life cycle assessment for two different products, which are glass and polymers, and using them for milk bottles. As you can see here, they will give you information about the energy, about the mass of the bottle, and about the number of time where they can be used during their lifetime, and then about their disposal. When you do the comparison or when you do the assessment, you need to take into account whether the raw materials are finite resources or whether they are renewable. You need to compare the total amount of energy, not just for the raw material, but also that needed for the making the product or during the production. If they give you the mass of the product, remember that the higher the mass, that means that we will need more of the transport, so more energy will be used for the transport. The continuous use or the reuse of the product as well, there will be some energy consumption here, and resources consumption, because if you use, for example, the glass bottle 25 times, you will need to wash it every time before you reuse it. And finally, the disposal, whether it's recycled or not. And then you can come to a conclusion whether this one is better or the other. But the main mark is not going to be on your final conclusion. It's going to be how you're going to assess or evaluate the different information they give you. Potable water is the water that is safe to drink. So potable water is different from pure water, because pure water means here that it's not mixed with anything. Potable water could have just some minerals or elements, other elements, so it's not pure, but it's safe to drink. We need to convert water to become potable water before we drink it, because water could have salts which sometimes are harmful, so we need to remove these, and also it could have some microbes which can cause illness, so we need to remove harmful microbes and salts which can be harmful. So potable water can be obtained from fresh water or from salt water. Fresh water, obtaining potable water from fresh water will need much less energy, but from salt water, it's a process called desalination, which requires high energy. So let's start with the process of obtaining potable water from fresh water. There are two stages. The first stage is that fresh water it contains some insoluble particles and microbes. So first they pass through sand filters where insoluble particles are removed. And then the water goes through sterilization tanks where they become sterilized using either chlorine, ozone or UV radiation. And so they become sterilized. We get rid of the microbes and then we can have it as potable water, which can be then used or becomes safe to drink. In case of the salt water, we have two different processes which can be used to remove the salt or for the desalination. First one is the simple distillation process, which includes heating the water in large tanks and then condensing the water, cooling down the vapors or the steam, and collecting the water. In this case, a lot of energy will be needed to boil the water, and energy will also be needed to cool the system down to condense the steam. And the wastewater as well will be too salty to get rid of or to dispose back into the rivers or to get disposed of into the oceans because it's too salty. So it's harmful to the environment. The other process is the reverse osmosis. In reverse osmosis, we put the seawater and we apply pressure and then we use semi-permeable membrane. When you apply the pressure, the semi-permeable membrane will only allow the water molecule to pass through but not the salt. So this is why it's called reverse osmosis because water will move but not the salt. And this is also a very it will require a lot of energy and it's a very expensive process because the membranes are very expensive to use or to buy, and they don't forget that the waste water as well will be very salty and also it's harmful to the environment. Wastewater treatment. Before wastewater can be get rid of or before wastewater can be released back into the environment, we need to treat it first. So wastewater will contain a lot of harmful ingredients that come from agriculture or from the industry or from the household. For wastewater treatment, the first step is the screening and grit removal. Screening and grit removal, the water passes through coarse filter where large particles only are removed in this step. So this is called the screening and grit removal. The second step is the sedimentation. Well, the water now is left in the sedimentation tank where the fine particles will collect at the bottom and the water will remain at the top. The top part is called the effluent. The effluent is then treated with aerobic bacteria to reduce the volume of the solid waste. So remember that the effluent is treated with aerobic bacteria. And then this effluent can even be used after that for drinking in some countries or in some areas if they are sterilized by adding chlorine, ozone, or UV radiation. If the effluent comes from or if the wastewater comes from industrial waste, then it might have some toxic material. So you need to get rid of the toxic material by adding chemicals and precipitating the metals. The bottom part of the sedimentation process is called the sediment or the sewage sludge. Sewage sludge is treated by digesting it anaerobically by specific bacteria. The products here or the remains after after the treatment can be used to make fertilizers, and also methane is produced which can be used as fuel. Corrosion. Metals can oxidize in air. They react in air to form metal oxide. Some metals are very reactive like sodium and they can react very quickly. Other metals are much less reactive like silver, which doesn't react with air to form oxides. Corrosion happens when a metal continues to oxidize. The metal will become weaker over time and eventually all of it will become metal oxide. Rusting is a form of an example of corrosion. It occurs when iron or steel reacts with oxygen and water. So here the rusting is not just a reaction between iron and oxygen, it's iron, oxygen and water to give you hydrated iron oxide. So this is the rusting. And this is a rusting experiment which shows the effect of both oxygen and water. Both of these are needed for the rusting. So to prevent rusting, you need to remove the substances that cause the rusting. So we know that we need oxygen and we need water. So you can remove oxygen by excluding oxygen by storing the metal in an atmosphere of an unreactive nitrogen or in presence of argon, which are unreactive. So basically in the absence of oxygen. Or we could use a desiccant. A desiccant is a substance that absorbs water vapor, so we keep the metal dry away from the water. We can also use physical barriers to oxygen and water by painting, oiling and greasing, or coating with plastic. Also, to prevent rusting, there are three different processes we can use. The first one is electroplating. Electroplating is a process where they use electrolysis to put a thin layer of a metal on the object. For example, you can use electrolysis to add a layer of silver, which is unreactive, on top of the iron. So you will prevent the rusting because silver will not rust. Or you could use what is called sacrificial protection. Sacrificial protection, iron can be protected if it comes in contact with a more reactive metal like zinc. So when iron is in contact with zinc, the in presence of oxygen and water, zinc is the one that is going to be oxidized because it's the more reactive one. So we sacrifice the zinc for the sake of the iron. Galvanizing is basically some sort of sacrificial protection where iron is coated here with zinc, and the zinc is the element or the component or the element that will be oxidized, not the iron. Polymers, there are different types of polymers, and the polymers are different based on the monomers they are made from and also the conditions under which these monomers are joined together. So we have low density polyethylene polymers and we have the high density polyethylene polymers. They have different properties. Lower density ones are flexible and reactive and can be made into films. They usually used to make carrier bags and bubble wraps. And the high density polyethylene polymers, they are strong, flexible, and resistant to shattering, and they are resistant to chemical attacks. So that we use them with plastic bottles, pipes, and buckets. So why they have different properties? If we look at the shape of the low density polyethylene, for example, they have a structure where the polymers chain are branched. Because they are branched, that means that the molecules are arranged randomly. So this is why they have different properties. However, the high density or polyethylene polymers are less branched and the polymer have less branching in the polymer chain, so the molecules are lined up very much more closely. They have much higher melting points as well. In terms of how they respond to heat, we have two different types of polymer. We have the thermo-softening and we have the thermostatic plastics. So thermo-softening plastics, they can melt when they are heated, so they can be recycled, and that involves melting them before making a new product. Thermo-softening plastic do not have covalent bond between neighboring polymer molecules, so the molecule can then move over each other when they are heated. Thermosetting plastic are the ones that do not melt when heated. They can only char and burn when heated. They are resistant to heat and that makes them very useful to make things that we don't want them to melt. For example, making electrical plugs. Extracting metals, there are alternative methods of extracting metals because earth resources of metal ores are limiting. We can extract copper from low grade copper. There are two methods of doing that. The first one is the phytomining. In the phytomining, they use plants to absorb metal compounds, and copper will gradually build up in the leaves of the plants. The plants are harvested, they are burned to produce ash. The ash will contain the metal compounds. Or we could use bioleaching. In bioleaching, bacteria is used to produce a leachate solution. That leachate solution will contain soluble metal compound. The element can be then extracted or can be purified to obtain the metal ion. For example, copper can be obtained from a solution of copper compound by a displacement using scrap iron or by electrolysis. Composite compound. A composite material consists of two or more materials with different properties. They are combined together to produce material with improved properties. What you need to know about composite material is that it has two components, the reinforcement and the matrix. The matrix bind the reinforcement together. These are some examples of composite material, the reinforcement material and the matrix in each. It's often possible to separate the reinforcement from the matrix by physical processes. Alloys of steel. Steel are alloys of iron that can contain carbon, which is a non-metal, and certain metal elements. Different steel have different properties depending on the different element that exists with the iron. So we have the high carbon steel, which has high component of carbon. These are tend to be strong and brittle. And we have the low carbon steel, which still have carbon as well, but less carbon here, which is softer and more easily shaped. And then we have the stainless steel, which has chromium or nickel, and they are hard and resistant to rusting. So high carbon steel are used for construction because they are strong and brittle, and low carbon steel are used for making cars because they are softer and more easily shaped. The difference between aluminium and magnesium. Aluminium is simply the metal aluminium. Aluminium does not react with water. The surface is protected by a natural layer of aluminium oxide. We used aluminium foil for cooking or in our household, and it's relatively lightweight. Magnesium is an alloy of aluminium with magnesium. It still has low density and but it's stronger than aluminium itself. Glass ceramic. So glass is transparent and hard, but it's brittle. What you need to know are the two different types of glass. So we have the soda lime glass that is made by a melting mixture of sand, sodium carbonate, and limestone. The other type is the borosilicate glass, which is made by heating sand with boron trioxide. Clay ceramic. So clay ceramic, you only need to know how to make clay ceramic. So clay ceramics are made by shaping wet clay and then heating it to a high temperature in a furnace, which causes crystals to form and